So I study star formation and how stars form, and what I look at are molecules. So the gas that condenses to form stars is mostly hydrogen gas, but it contains this small amounts, trace amounts of other materials. Carbon monoxide, water, formaldehyde, ammonia, simple what we call organic compounds. Now these heavy elements, carbon, nitrogen, oxygen, anything heavier than helium, weren't formed in the Big Bang. They were formed in stars. Stars that were much bigger than the sun, that created these heavy elements in their nuclei and then exploded. These supernovae, that when the star blows up, it sprays this material, this dirt, out into space, and then a new cloud can condense and make a new star, and it can explode again. And eventually, after many, many explosions, the gas can become enriched in these trace elements and have lots of carbon, nitrogen, oxygen. So these elements are out there. And in fact, the average carbon atom in your body has been inside 5 different stars. So you are literally made out of star stuff. Every carbon atom in you has lived in other stars. So you're made out of that material. You have a direct connection to these stars. Now, let's imagine that we're looking at stars forming today. There's some carbon in the gas, there's nitrogen in the gas, there's oxygen in the gas. We make a star, and we make the protoplanetary disk around the star, the things that has little solid particles called dust grains that are made out of these heavy elements. They become the planets, and so that material gets incorporated into the earliest planets. It also gets incorporated into things that will later turn into planets, and these are what we call protoplanets, or we see evidence for these things in the form of asteroids and comets, and the things that land on Earth, the meteoroids. When you look at these things that land on Earth and you examine their structure, you find that they're like black. Many of them have this kind of like tarry goo in them, and they contain complex molecules. So when I'm looking at things forming in space, I see these complex molecules from the stuff that the stars are forming from. So there's organic material. It's not really made out of life, but nature has made a way to make these complex molecules out there. And we're getting some really complex molecules with dozens of atoms, up to, I think the record now is 25. The list keeps getting bigger all the time. So we're seeing very complex molecules in the gas that the stars are forming from. And we see that these survivors from the early solar system have this organic material in them. Now, the Earth formed from this stuff, so it had a ready supply of this. Now, the problem with the early Earth was that as it was accreting material, it was basically getting bombarded by meteors all day, every day. And it was like 100 atomic bombs going off per day. And the surface of the Earth was molten. So not very conducive to life. But eventually, all the debris cleared, or most of the chunks of rock between the planets was incorporated into one planet or another. And then the Earth could cool. And when it cooled off, it was cold enough so that you could get a nice veneer of organic material that, it could accommodate an ocean, right? Now, where the oceans come from is still a subject of quite some controversy. Some believe that the water that forms the Earth's oceans came from the comets, and there's plenty of water in comets. Comets are basically big blocks of ice. They're dirty snowballs. Most of comets are water ice with some dark goo on them. So if a bunch of comets hit the early Earth, there's plenty of ice there that it can make water and make the oceans. There's another idea that the water was just incorporated into the stuff that made the early Earth, and when the volcanoes erupted, as they did in the early Earth, all that steam came out, and when it became cool enough, that steam could condense and fall to the ground. But in either case, the water is from the early stages of the formation of the solar system. So if you need water for life, this is where it came from. So the conditions of making stars has that organic material in it, and there's plenty of water there, there's plenty of carbonaceous materials. And then if you have an ocean and you seed it with constant bombardment by these carbon-rich meteors, you can easily imagine this ocean becoming enriched in this carbony goo, and then between here and there, somehow life forms. Now, that's a big question. You have the early Earth with the soup, and then you have life. But life happened really early on the Earth. We know the Earth is about 4 billion years old or so. The oldest rock on Earth is something like 3.5 billion years old. The oldest mineral, I think, is from West Australia. It's like 4 billion years old-ish. Life was around in the form of blue-green algae, the cyanobacteria, about 3.5 billion years ago, the oldest fossils. So that's not very long in the history of Earth. So it went from a magma ball to something with primitive life on it fairly quickly in the history of the Earth. And then evolution did its thing and made us, but it doesn't seem like that big a leap to go from a very organic, rich, watery medium to complex molecules, to self-replicating molecules, to cells, to us. The big leap, I think, was that first bit of the self-replicating molecules and then turning into cells. But nature found a way, and it happened really early in the history of the Earth.